So hello everyone, good day. Welcome back to our lecture series for General Chemistry 1 here in our YouTube channel. So today's lecture we will be discussing about stoichiometry. This is the fourth lesson that we will be discussing for under General Chemistry 1. But for today's lecture, it's just a part 1 of our topic since stoichiometry is really a long discussion. So today is just the part 1, and for the next week, I will upload the part 2 and the part 3. So thank you for watching my other videos, especially in my past lessons, and I hope that you will continue to support and don't forget to share the video so that other students also can study and learn more about the topic. So without further ado, let's get started in our discussion. So our discussion for today is all about stoichiometry part 1. So this topic will be discussing mass and chemical reactions, mostly in chemical equations. So here we will be learning how to write chemical equations using appropriate phase labels, symbols of reaction conditions, and the presence of catalyst. And also we will master the concept of balancing the chemical reaction. For our discussion overview next week, which is the part 2, this includes modes of substances. We will be learning about atomic masses, Avogadro's number, and the mole concept, and how these three are related in some calculations. Also, we will be determining chemical formulas, like how we could come up with molecular and empirical formulas, its rules, and also we will be learning about percentage composition. For our discussion overview in the part 3, we will be learning more on the calculation area in stoichiometry. So here, we will be discussing the quantitative relationship of reactants and products in a chemical reaction. This focuses on calculating the percent yield and the theoretical yield of a certain chemical reaction, as well as the determination of limiting and excess reactant on our chemical reaction, and also some related calculations. So now let's start with our discussion for chemical reactions versus chemical equations. So here, we know that during a chemical reaction, the ways in which atoms are joined together are changed. So it doesn't really necessary that the change term here is something like the chemical reaction can change the physical appearance or properties of a certain chemical reaction, but it just focuses on the rearrangement. So by means of rearrangement, this is this focused on the old bonds are broken and the new bonds are formed from the reactants that are converted into products. So here we have an illustration. This area here, these are the reactants. Usually, reactants appear on the left side of the equation. And then on the right side, these are the products. They are both separated by an arrow to indicate that the reaction proceeds from left to right. So the reactants are the ones that are consumed in a chemical reaction to form the products. Chemical equations also represent the transformation of one or more chemical species into new substances. So, okay, let's just discuss the reactants and products in a more detail. As I said earlier, the reactants are the original materials and are written on the left side of the equation. And also the products, they are the newly formed compounds and are written on the right-hand side of the equation. So it is always in this manner that reactants to products, unless that a certain chemical reaction or equation is stated as reversible. So when we say reversible, the products and the reactants can be either side of the equation. So unless it's stated, so um, you can interchange the both. But for most chemical equation, it's really proceeds in this way, that reactants to products. Okay. So let's go back to our illustration. Suppose that we don't know what these chemical compounds are. So what we need to know is that we need to determine the chemical formula for this so that we will be able to write the proper chemical equation. So not just an illustration like this. We know that a chemical equation is a shorthand expression for a chemical reaction. So we could say that probably this area here, this is a methane gas. So for methane gas, as you can see, um, it's bonded with 4 atoms of hydrogen, the carbon. So it reacted with 2 oxygen molecules, and then it forms carbon dioxide gas and 2 moles of water. So we also take into account, after we write the chemical equation, we also take into account the number of individual atoms of the elements present. So as I said earlier, we should be mindful on this because we will be using this in our calculations later on. So for methane, we know that it contains only 1 carbon and contains 4 hydrogen atoms. For oxygen gas, we know that it contains 4 atoms of oxygen because it's multiplied by its subscript and the coefficient. Always do this so that you could get the right number of the atoms present. For CO2, we also have 1 atom of carbon and 2 atoms of oxygen, and then for water, 2 atoms of oxygen and 4 atoms of water. Okay, so I hope that's clear. Chemical equations describe chemical reactions. So a chemical equation, we know this is a shorthand expression for a chemical reaction. So usually, in our problem solving, most of us are given not the chemical equation directly, but we are given by a certain word equation. So what we do in that word equation is that we convert that into a chemical equation. So how do we do that? So we do that by learning and familiarizing the chemical formulas that are, the chemical compounds that are mentioned in the word equation. So we need to learn the chemical species that are mentioned in a certain word equation. It is necessary because we are calculating quantitatively of our reactants and products relationship using chemical equations, not word equation. Okay, so here in our word equation, we have aluminum combines with ferric oxide to form iron and aluminum oxide. We cannot perform necessary calculations using word equations, so we need to write this word equation into chemical equations. So we know that aluminum is an element, right? Its symbol is Al in the periodic table, so we need to write that. And then it says that it combines with ferric oxide. Ferric oxide comes from the reaction between iron and oxygen atoms. So the symbol is Fe2O3. So we need to learn that also. And then after it reacts, it forms iron. Iron is Fe in the periodic table. And then aluminum oxide as well. So we have already converted our word equation into chemical equation. So it is really necessary because we will be using this in our calculations. Also, reactants are separated from products by an arrow. So as we have seen earlier, we separated reactants to products by a arrow, and then in our reaction between aluminum and ferric oxide, we also separated them to indicate that the aluminum and ferric oxide are the reactants, and the iron and the aluminum oxide are the products. Okay. The coefficients are also placed in front of substances to balance the equation. So after you write the word equation, you need to write the necessary coefficients in order to balance the chemical equation. So we know that if we glance in this first equation, the equation is not balanced, right? Because we need two two atoms of aluminum on the reactant side to balance the two aluminum in the product side. So we need to write 2 here. So as well as the other chemical species, so you need to inspect that if they are balanced. So here, the coefficients for iron also, we put 2 since we have 2 atoms of iron from ferric oxide. Also, we take into account not just the coefficients but also the subscripts, because the subscripts is the one that you need to multiply with the coefficients, and then if you add them together under the same species, you can get the correct number of atoms present in each side of the chemical equation. Now let's proceed in taking phase labels for a chemical equation. So it is necessary to label the chemical formulas present in a chemical equation so that you will be able to know its physical states. So for solids, we could write it as S, liquids for L, gas for G, aqueous these are substances dissolved in water, so we use AQ. We also have some reactions that require an additional symbol, and these symbols are placed over the reaction arrow to specify reaction conditions. So if we need heat in our chemical equations, in a certain chemical reaction, in order to proceed, we need to write a triangle above the reaction arrow, so that symbolizes heat. For photochemical reactions also, there is light. We put HV on top of the reaction arrow. So to further illustrate, using the same example that we had in aluminum and ferric oxide reaction, this needs a heat in order to proceed. So this is a thermal reaction, the example of a thermal reaction. So we need to write a triangle in the above the reaction arrow. And then the physical states also is necessary to indicate the symbols of the chemical formulas mentioned. So for aluminum, we know that aluminum is solid, so we put S. For ferric oxide, this is also solid. And then for iron is usually in liquid form, so we put L. And then for aluminum oxide, we also put S because this is solid. So mostly solids and mostly oxides are solids. Okay. Now let's go in the concept of balancing chemical equation. So in balancing chemical equation, there is a law that we follow for us to have a guide in balancing the right number of atoms present in a chemical equation. So this law is termed as the law of conservation of matter. It states that matter is neither created nor destroyed. So to further illustrate the law, we have here a reaction for the formation of water. The reactants involved are atoms of oxygen and atoms of hydrogen. So after this two substances reacted, they formed water. So what can you observe in this illustration? here you can see we have 6 oxygen atoms in the reactant side, and these atoms are bonded to one another. Then when the reaction with molecules of hydrogen happens, the oxygen atoms break down and attach to the hydrogen atoms to form the water. So as you can see, there is also 6 oxygen atoms in the product side. So therefore, these oxygen atoms just break down and attach themselves to the hydrogen atoms to form the water. So there is no cancellation, or there is no disappearance of certain atoms. They just broke down and combined to form a new compound. So that is the transformation usually happens in a chemical reaction. So in a chemical reaction, atoms are neither created nor destroyed. So this is an important process or concept that we need to learn to balance chemical equations. So in balancing chemical equation, this process is used usually by means of trial and error. Why is this trial and error? Because we are substituting different numbers of stoichiometric coefficients in each species in order for the chemical equations to be balanced. So these numbers that we are writing, or we are writing before the chemical formulas, are the stoichiometric coefficients. So the stoichiometric coefficients, this multiplies the number of atoms of each element in the formula unit of the compound that it precedes. Another thing that we need to pay attention when balancing chemical equations is that we don't need to change the species. So if we're given a certain word equation, and then we really wanted to balance the chemical equation, so no need to change the species. So just don't do that, because the word equation may be different na dayon in the corresponding chemical equations na it forms. So just to balance the word equation, you don't need to change the species, because it doesn't really represent the word equation anymore. We also do not use fractions, because the molecules also in a balanced reaction cannot be half a molecule. So usually it's really a whole number. As much as possible in a small number coefficient form. And also make sure you have the same number of atoms of each element on both sides. So this is the thing that we really have to do in balancing chemical equations. So the general procedure for balancing equation is that first, write the unbalanced equation. So as our example here, we have a combustion reaction of methane and oxygen. So we write that as this chemical equation, because we know that in combustion, always the products are carbon dioxide and water. Then, yes, make sure that the formula for each substances is correct. So after that, we write the unbalanced chemical equation. We balance this by inspection. So what we mean by inspection is that we need to check the number of atoms present on each side on every element that is present in the chemical equation. So we need to count and compare each element on both sides of the equation. So how do we do that is that we need to count how many carbon atoms, how many hydrogen atoms, and how many oxygen atoms present in both sides of the chemical equation. So for carbon, we know that we only have one atom of carbon here in the reactant side, because of the methane, it only contains one. And then here also in the product side, for CO2, we also have one. So the carbon atoms are balanced in this chemical reaction. But for hydrogen and oxygen, they are unbalanced since we have 4 hydrogen in the reactant side due to the methane. There are 4 hydrogen attached to carbon atoms, and then also here in the product we only have 2, which comes from the water. So this makes the chemical equation unbalanced. Also for oxygen, we also have 2 atoms based here in our O2. And then for our product side, for CO2, we have 2 atoms. And then for water, we also have 1. So that makes them 3 oxygen. This is also not balanced since 2 oxygen is not equal to 3 oxygen. So how do we balance this? So the third thing that we need to do is that balance elements that appear only in one substance first. So for this process, we balance the hydrogen first. So how do we do this? Is that we know that four hydrogen present in the reactant and only 2 here. So how do we make the product side equal to 4 hydrogen atoms? So we add 2 as the stoichiometric coefficients for H2O, because if we multiply it by its subscripts, it becomes 4 hydrogen atoms. Okay, so we have 4 hydrogen present on each side already. We don't need to add here in the reactant side because we already have 4 here. So you can write 1, or it's okay if you don't write. It's understandable that there is only 1 atom for methane that reacts. Then after we balance hydrogen, we balance oxygen. So since we know that there are 2 atoms in the reactant and then we have 3 here, how do we do that? I guess you need to recount the oxygen in the product since we already add 2 for the water, and then by inspection again for oxygen atoms, we already have 4. It comes from the carbon dioxide and the 2 moles of water. So 4 oxygen in the products already. So we need to add 2 here in order to have the 4 oxygen atoms on each side of the chemical equation. So that's how we balance the chemical equation. After that, let's check again if there is anything that needs to be balanced, any element that needs to be checked. So when finally done, check for the smallest coefficients possible. So as we can see here, all the coefficients on the chemical equations are in the smallest form. So now let's go in our example problem number 1. So write the balanced chemical equation describing the reaction between propane or C3H8 and oxygen to form carbon dioxide and water. So as we could observe from this problem, this is a combustion reaction of propane and oxygen. And also, we take note that for combustion reaction, the products will always be carbon dioxide and water. So the first thing that we need to do is to write the chemical equation of the problem, unbalanced chemical equation of the problem. So we write here propane reacts with oxygen to form carbon dioxide and water. Okay, so after that, we check it by inspection the elements involved in this unbalanced chemical equation. So for in this reaction, we have 3 elements involved. We have carbon, oxygen, and hydrogen. And then we also count how many of these elements are present in each side of the reaction. For carbon, based from propane, we have 3 carbons present in the reactant side. And then also here in carbon dioxide, we only have 1 for the product. So this makes the chemical equation unbalanced because they are not balanced already in the carbon atoms. For oxygen, we have two coming from oxygen gas. And then here in the product side, we have two from carbon dioxide and then one from water. This makes a total of three oxygen atoms, which is also unbalanced due to the different numbers on each side. For hydrogen also, in propane, we have 8. And then for water, in the product side, we have 2. So this is also an unbalanced numbers of hydrogen atoms on each side. So after we balance it by inspection and prove that the chemical equation indeed is not balanced, we need to balance each element in each side of the chemical equation. So the first element that we need to balance is hydrogen. So let's write again the chemical equation. So we know that in hydrogen, we have 8 in the reactants and then 2 in the product side. So we need to add a coefficient in the product side in order to come up with also 8 atoms of hydrogen. So since water is the compound that has hydrogen here, this species, this is the one that we will be adding the coefficient. So how many? How do you think? What do you think? How many hydrogen? What proper stoichiometric coefficients should I put in order to balance the hydrogen atoms? Yes, it's 4. So that there will be equal 8 hydrogen atoms on each side of the chemical equation. So we take note on this equation. So we'll be using this in balancing another element. So the next element that we need to balance is carbon this time. So using the above equation, so we know that in carbon, we have 3 in this reactant side due to propane. And then we also have 1 here from CO2. So we need to add here the stoichiometric coefficient of 3, right? So that to balance the number of carbon atoms. And it should be written here in CO2 since this is the only chemical species that has carbon in the product side. So we'll be using again that above equation to balance the oxygen. So this is the last element that we need to balance. So here we need to inspect again in oxygen since we already add 4 here. So there will be this is not 3 oxygen atoms anymore. So we need to count how many oxygen atoms in the product side. So we have 3 times 2 here in CO2, so this is 6. And then here we have 4, so a total of 10. So here in our reactant side, we only have 2 oxygen atoms. So we'll be adding here the coefficient of 5 in order to balance the 10 atoms of oxygen. So since we have 10 here in the products, we should have 10 here in the reactant. So 5 times 2 is 10. So this will be the final the final balance chemical equation of the problem. Yes, this is the final answer. Now let's go to example number 2. We need to balance the chemical equation provided. So this is a chemical reaction that involves the reaction between FeCl3, which is iron 3 chloride. So I just need to write na lang the names of the chemical compound that are involved in this chemical equation. So this is iron 3 chloride, and then it reacts with ammonium hydroxide. This is ammonium hydroxide to form this compound, which is iron 3 oxide hydroxide. This is kind of complicated compound. And then it also has a product of ammonium chloride. Okay, so these are this is the chemical species that are involved in this chemical equation. So what we need to do is to see what is the first element that we can balance. So based in our reactants, we have 3 chlorine here from iron 3 chloride, and we also have here only 1 from ammonium chloride. So how do we balance chlorine this time? We balance chlorine by writing 3 on the product side to compensate the 3 atoms from the iron 3 chloride in the reactant side. So we need to write 3 here to come up to balance the chlorine atoms. After that, since the balance na ang chlorine atoms, we will be balancing ammonium compound. So we know that here we have already 3 moles of nitrogen. So how do we do this is that we write 3 also here to balance the number of nitrogen atoms from the ammonium. So the final equation is written as this, since we already have 1 Fe atoms here. It's balanced. We also have 3. And then we also have 3 ammonium atoms. Here also 3. And then also we have 3 oxygen coming from the from ammonium hydroxide, and 3 oxygen from iron 3 oxide hydroxide. Also the hydrogen atom. So finally, this will be our balance equation in this chemical reaction. So if you're confused by determining the correct number of atoms that are present, so you could write them individually. Okay, so for our practice problems, I will be giving you 2 problems that you need to do. Both of them requires balancing chemical equation. So the first problem is that these are all word equations. So you need to write this word equation into chemical equation and balance them. I will not read the problem anymore, so I hope that you will take time to read each of them. And then here for problem 2, just fill in the proper stoichiometric coefficients that you need to write in order to balance the equations. So this is the end of our lecture for today. So mostly this talks about the first topic of stoichiometry, the very basic, which is the balancing of chemical equations. So after this, we'll proceed on the higher calculations, especially in the relationship of moles, atoms, and Avogadro's number, and then also calculating molar mass and determining chemical formulas and percentage composition of the compound. So I hope that you understand this lesson, and thank you for listening. And then if you want to send me your answers, you can send me here in my personal email, and also check out the other videos that we posted in our YouTube channel. And then I hope to see you on the next lesson. So thank you for listening and have a great day. So thank you.